Okay, so today we're going to be going over capacitor replacement in an indoor HVAC unit or furnace and an outdoor HVAC unit. We're going to be going over the different tools that you need to complete the job, the difference between a dual run capacitor and a single run capacitor, and just simply how to safely test and replace the capacitor itself. So let's get started. So a capacitor is a small gray object located inside the indoor and the outdoor HVAC unit. It's designed to help jumpstart the motor and to flow energy into that unit to keep it running. There are two types of capacitors in these units: the dual run capacitor and the single run capacitor. The difference between the two is that the single run capacitor controls the circuit to the fan and the circuit to the fan only. It has two sets of metal terminal pins right here, feeding energy from the ground to the fan. The dual run capacitor will be controlling two circuits. It'll have one set of terminal pins that'll be feeding energy to the fan and one set of terminal pins that'll be feeding energy to the Hermetric compressor. So, controlling one circuit to the fan, controlling one circuit to the compressor. Two circuits. Now on these dual run capacitors, you'll find three sets of terminal pins. On this one, you have your ground or common and a fan terminal pin. But also you have terminal pins for the Hermetric compressor. So essentially this capacitor will be feeding energy to the fan as well as the compressor. If you look at the top of the capacitor, you can see C for common, fan for fan, and Herm for Hermetric compressor. So that will be your compressor. You may want to look into ways of labeling these yourself, just in case enough rust ever builds up on the top of the capacitor to where you can't read what it says on the top right there. With that knowledge of what these devices are, let's go over how to replace them, starting off with the indoor unit, or the furnace. The first step you're going to want to take every time in changing the capacitor is to turn off the unit. You can do this firstly at the breaker box, finding the switch that is labeled furnace and turning it off. Now with that off, you want to return to the furnace and locate the disconnect, or discharge. Find that discharge, pull it out, and now you can have the utmost confidence that this unit is not operational. From here, we're going to want to take the cover off the unit, and you can normally use a 1/4 inch or 5/16 nut driver to do this job. You may also end up using a Phillips head or a flathead screwdriver, you never know, but regularly it'll be a 1/4 inch or a 5/16. Then you want to locate the bolt that's holding in the capacitor. Locate that bolt, unscrew it, and that'll free up your capacitor to do whatever you need. Now that you have it free, a good practice that you're going to want to adopt is to ground out the capacitor. Now you're going to want to use something metallic but that has a rubber handle because, well, you don't want to get shocked. Take the rubber in your hand and just rub the metallic part along the terminal pins just like that. Now touching these two terminal pins with something metallic, it completes that circuit. If there is any energy left in this capacitor, it completes that circuit, grounds it out. Any leftover energy, it won't reach you. From here, you're going to want to find a flathead screwdriver or a set of pliers to help lift the wires off of the terminal pins. Always do the fan and then the ground. We then test to see how the capacitor is operating. We're going to pull out our meter. We're going to set our dial to MFD, which stands for microfarad, which is the measurement of capacitance in the capacitor. Switching that dial to MFD, and now we want to find out what is the minimum capacitance that this capacitor can have in order to work properly. Now there is a method to figuring out what the maximum and minimum capacitance is. To figure this out, you want to look at your capacitor and locate the percentage. Locate it right here, and in this case is 3%. Then you want to locate your compressor rating number. Located right here, and in this case is 7.5. Take out a calculator and multiply 7.5 by 3%. You'll get 0.225, which rounds off to 0.23. Now with that number in mind, we're going to go back and we're going to say 7.5 plus 0.23, and that'll give you 7.73, our maximum. Now we're going to want to go back and say 7.5 minus 0.23, and that'll give us 7.27, our minimum. Now as long as that meter we just had says that our capacitor falls between these two numbers, we're good. This capacitor is good. And the same math formula will apply no matter what these numbers are. And now we're going to take our meter, and with the two testing prongs right here, we're going to apply them to the terminal pins on our capacitor. And with that, we'll be able to see whether or not this capacitor falls within that window. So we're going to want to apply them just like this. And sometimes you may have to just scratch them around, and this capacitor comes out to 7.47, which was within that window, so that makes it good to go. Now we applied this formula and tested the capacitor that we're putting in. We now want to test the one that we're taking out, just to make sure the one we're taking out is bad. And it goes the exact same way. Find the compressor rating number, in this case it's 7.5, and multiply that by the percentage. In this case is 10, so 0.1, and that equals to 0.75. We now add 7.5 to 0.75, and that gives us 8.25. That will be our maximum. We then go and subtract 7.5 from 0.75, and that gives us 6.75. That will be our minimum. Take out your meter and connect the 2 testing prongs to the terminal pins, and whatever it reads will need to fall within that window. And if it doesn't, then that means that it needs to be replaced, which it does. So we're going to be taking that one out and putting this one in. We do so by connecting the wires back onto the terminal pins. You're going to want to put the cover back on, securing those bolts into place using your 1/4 inch or your 5/16 nut driver. Put that discharge back into place and then return to the breaker box. Find the one that says furnace and switch it back to on, and your AC's back on. You're done. Now onto the outdoor unit.